Hello. In this lesson, we will be discussing limiting and excess reagents. Now, to begin with, let's consider a bicycle. A bicycle, in its very simplest terms, is two wheels and a frame. So, a bicycle is two wheels and a frame. So, those are essentially the parts. I know people who are more complex bike makers, whatever, they'll have like thousands of parts, but for right now, we're just going to consider a bicycle, two wheels, one frame. Now, if I'm going to make a bicycle, and let's say somebody's given me 5 wheels, 1, 2, 3, 4, 5 wheels, but I'm only managed to scrounge up one frame. So, despite however many wheels I have, I can only make one bicycle. So this wheel goes here, this wheel can come here, but I'm left with 3 wheels and nowhere to put them. These 3 wheels are, in a sense, excess. They're just extra wheels. I can't really do anything with them. So this idea of a bike having like excess wheels and being limited by in this case, the number of frames, well, this idea can be now extended to chemistry and chemical stoichiometric equations. So when we balance a chemical equation, we give the ideal stoichiometric relationship among the reactants and the products. This just means that I need exactly this much of A and this much of B, and it makes this much of C. But in reality, you can't get everything right down exactly to the atom or to the molecule. So usually we'll have a reactant that's not used up in the reaction. And this is called what's the excess reagent. So this excess reagent is left over at the end of the reaction because there's no more of the other reagent, which is called the limiting reagent, because it's been used up. So this limiting reagent essentially limits the amount of products that I can possibly form. So if I take a look below here, I have my blue diatomic molecule here, and I have my red one here. As I move from my reactants to my products, well, all the red ones, they get used up. I make my product here, but now I have some excess of my green kind of diatomic molecule. So the red one here is limiting, and my green one is in excess. That's because they've reacted, the reaction's done, and I still have some of the green ones left over, therefore it's in excess. And this happens in every single chemical system, because no matter what we do, just the limitations of our measuring systems, we're always going to have one being in a little excess than the other. And sometimes this is favorable according to like thermodynamic conditions or reaction kinetics. We want at least one of them to be in excess to produce the product we want. So let's take a look at this kind of mathematically. So here's an example. I have the moles of reactants given. So I want to find the limiting reagent in the reactant in excess when I have 0.5 moles of zinc react completely with 0.4 moles of HCl. So first thing, let's write out balanced chemical equation for this reaction. So I have zinc and I have HCl. Oh, give a little bit of space because I'm going to take it back. HCl. And zinc plus HCl, well, this is single displacement reaction. I'm going to make zinc chloride and hydrogen gas. So right off the bat, pretty easy to balance. I'll just throw 2 into here. And everything else is balanced. I'm good. Second step, I want to calculate the amount of available moles of each reaction in the chemical, for each moles of reactant in the chemical reaction. Well, that's pretty easy. That's been given to me. That's why this type of example is a lot easier. I don't have to do this calculation. So I know I have zinc, well, I have 0.5 moles, and HCl, I have 0.4 moles. Now, using my balanced chemical equation, I want to see if I can determine the mole ratio of the reactants in this chemical equation. Well, that's pretty easy. I have 1 zinc for every 2 HCl. So I have a 1 to 2 ratio here for my reactants. Next, I want to compare the available moles of each reactant to the moles required to complete the reaction using my mole ratio. So this is where I'm going to use my known. So I have, let's say, 1 mole of zinc for 2 moles of HCl, and I'm going to try to figure out how much zinc am I going to need if I use up all of my HCl. So I'm going to compare it to, I'm not sure how much moles of zinc, but I'm going to see if how much I'm going to have if I use up all of the 0.4 moles of HCl. So I'm going to just do quick cross multiplication, and in the end, I'm going to say that's 2.2 is going to be equal to the number of moles of zinc that I need when I use up all of the HCl. So that's telling me 2 very important things. Since this is less than what I have, so it's less than what I have, because remember we have 0.5 moles of zinc, and if I've used up all of my HCl and I still have some left over, this means it's in excess. So you have less at the end than what you should have, and that means it is in excess. Less is excess. So the key idea here is I've used up all of this, or at least I figured if I'm going to do this reaction, I've used it all up, and I'm only going to need 0.2 moles of the zinc. I have 0.5, so I'm going to have 0.3 left over. So that's going to be very, very easy to see. So this one I just did for just trying to find out how much zinc I'd use if I use up all my HCl. Let's try it the other way. Let's see how much HCl I'd use if I used up all of my zinc. So I'm going to flip around my ratio. So in this case, my known ratio is 2 moles of HCl to 1 mole of zinc. I want to find out how much HCl I'm going to need if I use up all of my zinc. So all my 0.5 moles of zinc. And let's see. Doing some quick cross multiplication math, I'm going to find out that I'm going to need 1.0 mole of HCl, because 0.5 times 2 is 1 mole. So I'm going to find out I need 1 mole of HCl if I use up all of my zinc. Now, do I have 1 mole of HCl? No, I only have 0.4. So that means if I have too much of this that I need, this means that HCl is going to be my limiting reagent. So I found out here, no matter which way I did it, I still found out which one was limiting and which one was in excess. So in this case, my excess is going to be zinc, my limiting is going to be HCl. So HCl is limiting how much product I can possibly make in this reaction. So this right here is the hardest thing to kind of get your minds around. If I only have 0.5 and I multiply it by 2, I'm going to make 1 mole or need 1 mole of HCl. But because I don't have that, that means it's going to be limiting. If it's the other way, like I showed you with the zinc, where I only need a small amount of what I do have, that means it will be in excess. All right, so let's see an example where we're going to calculate using the masses. And this is just a little bit more involved in that we have to use our periodic tables and molar masses and convert back and forth from each other. So in this case, I want to find the limiting reagent, and the reagent or reactant in excess when I have 1.5 grams of calcium carbonate react completely with 0.73 grams of HCl. So first of all, write a balanced chemical equation. So I have CaCO3 plus HCl. Well, I'm going to get a couple things. I'm going to get calcium chloride, I'm going to get carbon dioxide, and I'm going to get water. So right off the bat, easiest thing, again, nice little 2-to-1 ratio between my reagents. 1 calcium carbonate to 2 HCls. So now I have to find out how many moles of each do I have. So I want to find the number of moles of calcium carbonate. Well, it's going to be the mass over the molar mass, which is 1.5 grams, over the molar mass of calcium carbonate, which I do have to figure out. So calcium is 40 plus 12 plus 16 times 3. Oh, nice even 100 grams per mole. So 1.5 divided by 100. Oh, gives me 0.015 moles. So the number of moles of HCl, figure out very similarly, mass over molar mass. This is one of the key kind of like little calculations that we always do. So we have 0.73 grams over the molar mass of HCl is 36.5 grams per mole. 0.73 divided by 36.5 gives us 0.02 stick figs moles. So right off the bat, like here with the number of moles, I can pretty much tell which one is going to be limiting and which one is going to be in excess, but I'm still not sure, so I'm going to continue on with my calculations. So now that I have the number of moles, I'm going to have to use my mole ratio to figure out which one is limiting and which one's in excess. So my mole ratio is 2-to-1. So my known is, all right, I'll put the 2 on here, 2 moles of HCl for every 1 mole of calcium carbonate. And I'm going to figure out how much HCl am I going to need if I use up all of my calcium carbonate. So X mole HCl, and I had 0.015 moles of calcium carbonate. So, doing some quick math, I'll know I'll have 0.030 moles, and that's equal to the amount of HCl that I need. Alright, so now I gotta think, do I have 0.03 moles of HCl? Looking back, no, I only have 0.2. So that tells me one very important thing. If I only have 0.2 moles, that means this is too much. That means this is limiting. So it's telling me that HCl is going to be limiting the amount for the products I can form this reaction. If I do it the other way, so 1 mole calcium carbonate to 2 moles HCl, and that's going to give me, 0.020 moles HCl. Do my quick math here. I have 0.2, 1 over 2, 0.01 mole calcium carbonate. Well, this is less than the 0.15 I have. So this is less, therefore this is excess. So right now I know what's my limiting and what's my excess. I don't have to do both these calculations. I'm just kind of showing you it works either way. So if HCl is limiting, then, and this is excess, so I know that however much HCl will determine the amount of product that I'm going to need. So I found what's limiting and I found what's in excess. Extensions of this would be how much of the products you might make, or percentage yield, or various different things that we're going to get to in future videos.